So today I'm going to do the presentation of a methodology for the maintenance program of high voltage substations. So just I have some problem with my, okay, I hope. Okay, so the why maintenance programs for high voltage substations and what are the different types of maintenance strategies? In fact, this presentation has been divided in two parts. The second one is very small. So why maintenance programs for high voltage substations? The best practice to avoid breakdowns and not to compromise personal substation safety is to apply proper maintenance. So this leads to the necessity of applying a multitude of maintenance actions, inspections, and tests in order to collect enough information on the actual condition of the breakers, transformers, and so on. So thanks to all this information, good decisions can be made in time. Next slide shows what kind of group of actions have to be taken. So first step is to do the inventory. In the left side, you see like transformers, breakers, batteries, measure transformers, sectioners. Second step is to do an observation and testing of what? Of breakers and transformers, in doing inspection and testing, and in collecting information from monitoring. Step 3 is to do the analysis of the data that you have recorded. Thanks to all these informations, now you can plan your interventions for repair or refurbishment. So first step, the inventory. The device chosen for the inventory can be a circuit breaker, a transformer, a selector. Inventory instructions examples. Here it's for Hydro-Quebec what they use. 1D for circuit breakers, 1M for measure transformer, 1U for power transformers with OLTC, 1H for storage battery, 1X for selector. Device attributes, the manufacturer date should be written on the equipment's nameplate. This nameplate is really important, and in every testing or report, it has to appear. First use date, warranty due date, device specifications like exploitation number, the occupancy, the utilization code. This information is important because it helps you, like it's written available, under an evaluation, in reserve, in repair, in service, engaged, out of service, incomplete, discard. The model, the serial number, manufacturer reference number, command number, catalog number, the maintenance notice. All this information is really important if you want to do your maintenance properly. And some specific characteristics as nominal voltage, nominal current, the braking capacity, mechanism category, the other information like the location to help localize the equipment, manufacturing drawing number, initial commissioning testing, timing, motion. Here you have an example of breakers database. Here you can see the type on the left, the manufacturer, the serial number, the technology used for this breaker, the year of manufacturing, the substation, and also the kilovolt here. For the step 3 is the observation and testing. So the information on the apparatus, it comes from the inventory. The inspection and testing, the actions to be repeated on a periodic basis. And the monitoring, it's a recording from monitoring systems. Here you have an example of table of our breakers. 1,000 operations. And you can notice here the limited inspection is including the routing inspection. The provisional inspection is including the limited inspection and the routing inspections, and the same for the complete inspection. I have done. Sorry, I have a problem. The required or recommended test for breakers linked to international standards. Here you can see, for example, the contact timing test, travel and velocity test, functional test, vibration test. It's a recommended first trip test, and also contact resistance test, dynamic resistance, and all the red are the Zensol test that we do with our instruments. The step 3 is the analysis. So this database organized for each piece of equipment, the data collected, and it may include the first test, results over time, repair interventions, various information. So this information serves to conduct analysis to determine the type and urgency of maintenance interventions. It serves also as historical data for future statistical and durability studies. So it's important to keep all this information. The analysis is done usually teams of highly trained engineers and technicians process all the information gathered in the previous sections and stored into well-organized database. These teams have the responsibility to reach a verdict based on the analysis of available information, and they can determine the required actions and priorities. So this information is put into a specific database used to prepare interventions. Example of collected data for breakers. So here you see the breaker serial number, the type of the breaker, oil, air blast. The inspection, it's provisional, here it's limited. And the kind of test, here we can see contact timing test, travel motion, resistance, oil dielectric, oil gas analysis, moisture. And the results are reported in reports which have an index, the date, and then the initials of the ID of the operators. And finally, the step 4, the intervention. So this is the part that organizes and coordinates the inspection sequences, so the maintenance people can prepare the required maintenance actions in advance to increase global efficiency. The purchasing department to buy the parts needed for the maintenance, the warehouse, the maintenance teams, the operators, and also here also it serves as historical data for statistic and durability studies. Specific database for maintenance interventions. This specific database has to contain the equipment serial number to identify the equipment being analyzed, analysis report number that details the findings and recommendations, the advisory number, if any, priority level of each recommendation, the deadline date for the intervention, analysis date, names of persons responsible. Example of advisories for breakers. Here you can see the serial number of the breakers, the report, the identification of the advisory, the deadline date, the priority, if it's urgent or not, the analysis of the data analysis, and who has done the analysis. Example of advisories. So advisories are reports that inform the maintenance manager on what to do on each equipment. It contains at least a list of concerned equipments, a list of actions to do, a list of parts, a list of special tools, drawings, and some special instructions. So the interventions, once the advisory is initiated, interventions can now be planned. For example, the result of a complete inspection of an interrupter module may reveal a critical condition that may require an intervention program on all similar breakers. This required coordination between network administration and maintenance teams. A list of to-do actions, parts, and special tools must be determined, not to mention training, quality assurance, budget cost, control, etc. Once the intervention is completed, keeping record of it is a crucial matter for comparison and future analysis. A part's repetitive failure, for example, may raise concerns on more critical problem or a design flaw. This may influence the future of an equipment family, systematic replacement or refurbishment. Example of complete interventions. Here you have the action plans, the to-do list, the teams involved, the schedule, start date, end date, the completion date, and who was responsible of this. So, on conclusion, the first part presentation has given the basics of setting up a maintenance program. And this presentation is based on our personal experience with Hydro-Quebec's maintenance program. So next step is, if you succeed to set up a good maintenance program, the next step is to ask yourself about the efficiency of what you are doing. So what are the different types of maintenance strategies? And this morning, I was thinking how I could answer to these questions. And I have simply asked Bing, my friend Bing from Microsoft, and this is the answers. And I found them very interesting. So I changed absolutely nothing. I just put the answers, and I have put in yellow what seems to me really important. So according to Beans, he said, there is no definitive answer to how many types of maintenance strategy exist, as different sources may classify them differently. It's exactly what I think, because I learned that there were three, sometimes they say four, others they say six. So it's really hard. So in fact, so I complete his answer. I say his answer, not its answer. One common way to categorize them is based on the degree of proactivity involved in planning and performing maintenance tasks. According to this approach, there are four main types of maintenance strategies. So the first one is the reactive maintenance or no maintenance strategy. This is when maintenance is only performed after an asset fails or breaks down. There is no planning or preparation involved, and the goal is to restore the asset to its normal operating condition as quickly as possible. And this strategy may be suitable for non-critical or low-cost assets that are easy to repair or replace, but it can also lead to higher downtime, safety risk, and repair costs in the long run. The second one is rain-to-fail maintenance. This is when maintenance is deliberately deferred until an asset fails or reaches the end of its usual life. There is some planning and preparation involved, such as having spare parts, tools, and procedures ready to fix or replace the asset when it fails. And the strategy may be suitable for non-critical or low-cost assets that have a predictable failure pattern and low failure consequences, but it can also result in wasted resources lost productions, and reduced asset reliability. Preventive maintenance. This is when maintenance is regularly performed on an asset in working conditions to reduce the risk of failure and extend its lifespan. There are two subtypes of preventive maintenance: time-based and usage-based. As you have seen in the previous presentation, you have, like for the breakers, you have 1 year, 4 years, 8 years, and 1,000 operation. So this is a usage page. Time-based preventive maintenance is when tasks are scheduled on an asset at a certain time interval, such as every month or every year. Usage-based preventive maintenance is when tasks are scheduled on an asset based on its operation, such as after a certain number of hours or cycles. And this strategy may be suitable for critical or high-cost assets that have a high failure rate or high failure consequences, but it can also result in over-maintenance, under-maintenance, or unnecessary downtime. It's exactly what happens when you have a good maintenance programs, but you don't know, a lot of times you touch to some transformers or breakers that they do not need to be open because they're in good health, in good condition. So this is the risk when with this strategy, and I have seen it many times. And the predictive maintenance, it's exactly what we wish to do, and this is when maintenance is performed on an asset based on its actual condition and performance rather than on a fixed schedule or usage. This involves using sensors, data analysis, and machine learning to monitor the assets, parameters, and detect any signs of deterioration or malfunctions. This strategy may be suitable for critical or high-cost assets that have complex failure modes or low failure consequences, but it can also require high initial investment, technical expertise, and data quality. These points are really important: the initial investment, technical expertise, this is for sure, and data quality. If you have good data, you can take a good decision. If you say you have a lot of data, we usually say garbage in, garbage out. So we have to be careful when you get a lot of data. So, of course, I cannot finish this presentation without talking about vibroacoustic. Is an example of technology that could help to establish a predictive maintenance for high voltage transformers with WLTC of high voltage breakers. And of course, the next slide, I cannot finish, as I told you, without talking about Zensol. And so here you can see some vibroacoustic sensors, which are accelerometers here on the transformers, here on breakers. And this is like a stethoscope while listening to the transformers and breakers online and offline, which is the trending 2 days, because we have we need not to stop the breakers or the transformers. So the effort today is to try to do a maintenance of the high voltage breakers and the transformers when they are online, not offline, because like the old maintenance programs used to put your transformers offline, your breakers offline, and you put all your cables. It's a heavy testing, which a lot of people are involved, because you have to stop. So the administration, the network is evolving, the security is evolving. It's a lot of, it's a really heavy process. But of course, what we are trying to do at Zensol is we are promoting the vibroacoustic, and thanks to the vibroacoustic, online and offline, we are able to assess the condition of your breakers or your transformers. And just quickly, the vibroacoustic diathesis, the technology has been patented by Hydro-Quebec in 2001, and since 2006, we are doing the promotion of this technology, and of course we try to bring you to the predictive maintenance thanks to this technology. So thank you for listening. So
Great.
Randy,
Thank you very much, Fouad. Excellent presentation as usual.
thank you.
Question: is there an industry standard where this Zensol test is based from? If so, what is it?
Oh, it's the vibroacoustic testing has been recommended by CIGRE and IEEE, and I can give the exact. I'm not strong in the exact number, you see, but I can send it to your
right. Okay,
yeah.
I'm going to put your email address.
Yes, please.
In the chat here, everyone. You can ask Fouad these detailed questions after the forum today. Next question: how is the Hydro-Quebec maintenance strategy different from NFPA 70B?
Oh my God, I cannot answer to this question because I don't know the NFBP. As I told you, I'm not strong in the.
Yeah, NFPA 70B is an industrial electrical maintenance standard. So Mike, the better question might be, oh, here, Sergio, you can ask the Sergio Pineda, our next presenter, is asking that question.
As I told you, if I got this question by email, I could refer it to the to some responsible in Hydro-Quebec,
yeah,
and I could answer precisely. I don't like to say not good answers. Today I don't know, but tomorrow I will know. But because I'm going to learn,
right? Okay.
So I could answer his question without any problem.
But I would assume that Hydro-Quebec has a fairly rigorous maintenance strategy for all of their substations, correct?
Yeah. Oh yeah, no, they have like I call this book is like a Bible, and I know exactly its references. I could give it its TET 1000. There is some reference, and each electrician or technical support has this book and knows exactly what he has to do on this kind of breaker, this kind of transformer. He has a lot of checklist, a lot of job aids, a lot of procedures, a lot of test plan. It's really it's a huge work that has been done. And what is interesting is that every 2 to 4 years, some procedures are reviewed and revised. So this way, it's always like at the top of the knowledge.
Right.